All right, go ahead and turn the page. We're going to deep dive into FRQ number 1. All right, so FRQ number 1, function concepts, will always require a graphing calculator. So when you see FRQ number 1, it is always calculator allowed. How many decimal places do we need for our answers? 3, right? Right here, decimal approximation reported should be accurate to 3 places. Okay? It's the same thing I've told you all year long. Some of you still only give me 1 or 2. And get out of that habit. It won't be accepted here. 3 decimal places. Okay? It will have 3 parts that focuses on the content from units 1 and 2, but never in real-world context. You may be asked to work with function composition, inverse functions, function input-output values, zeros of a function, in behavior of a function, and identification of the appropriate function type to construct a function model. We'll always have the same point count by skill, so a total of 6. Let's go ahead and look at here. Summary points. The question stem will be presented with 2 functions. That's what you're going to be given. One will always be analytically, meaning you'll have the equation. The other one will be given either graphically or numerically with a table. And the questions will involve working with both functions. Function types. You could have polynomial, that's linear, quadratic, cubic, any of those, right? Rational. It's a fraction. Polynomial over polynomial. Exponential or logarithmic. Calculator notes, things you should be able to do on your calculator. Graph functions, we're doing that today. Solve equations, including graphically by finding points of intersection. We're doing that today. Find zeros, might have to do that, we've done that before. And evaluate using stored values. Done that before. Okay, each part is worth 2 points across all 3 parts. May be asked about, but any of these bullet points here, not necessarily all of them, but any of these. So you could be asked about function composition. That one I think I've seen on almost all the FRQ style ones that I've seen. It's function composition. Inverse functions, evaluating or determining that an inverse function does not exist. Function input-output values, zeros of a function, in behavior of a function, using limit notation, identification of appropriate function type. And then part C will always have a reason point that will require you to demonstrate your knowledge of pre-calc concepts. All right, turn the page. Let's go ahead and do this one. It's our first FRQ style 1. I want you to start by reading through the problem, see what it gives you, read through the question stem, and then look at question AI. Read through it and see what it needs you to do. Even try it out. Let's talk about it together. I've had some time to look at it. All right, what do they give you? First off, the table. Which function is our table? F, right? We see that right there. They also tell us, might be important later on, it's an increasing function. It's always going up. What else do they give us? Which they give us as a equation. Isn't that what they said they'd do right here? One analytically, one either graphically or numerically. Yeah, they've done that, right? One numerically in the table here, and one analytically as an equation. All right, AI. They've defined h of x. What is h of x? G of f of x, right? That's what h is. What do they ask us to find? Find h of 5. So we want to know what is h of 5. Now, let's go ahead and read some more. There's some other information. Find the value of h of 5 as what? So they want it as a decimal. So pay attention of how they want the answer. Or indicate that it's not defined. Maybe that's the case. Show the work. This is actually a new instruction here this year. Show the work that leads to your answer. Again, as I've said, show your work. Don't just give an answer. So what would be work that I could show for h of 5? What would I do? H of 5 equals what? G of f of, not x this time, 5. What would we find first? F of 5. So where do I go to find f of 5? What is f of 5? So my next piece of work would be G of 34. Show that. All right, what do we do next? We have G of x right there, don't we? Plug it in. Now, you could at this point, I think this is enough work to be able to just give the decimal, but if you want to just be extra careful, show plugging it in. Say, hey, that's 34 cubed minus 14 times 34 minus 27 over 34 plus 2. That's the plug-in that needs to happen. Now, don't do that by hand. Go to your calculator, plug that in, and get the decimal. So go ahead and do so. So let's see, go into our calculator. I'm just going to go ahead and plug it in. 34 cubed minus 14 times 34 minus 27 over 34 plus 2. Now, you could type it in like I did here. If you have it inputted as y1, then you could then just do y1 of 34. Doesn't matter. Did we get this answer, guys? 38,801 over 36. You could give that, could write that down. Say, all right, 38,801 over 36. But is that how they want the answer given? No, what do they say? So how do I get this as a decimal? There's a couple different ways you could do it, but once you're here, it's easy to just do a conversion. Where do we go to convert to a decimal? Math, and which one do I pick? Number 2. If you're on a Casio, it's just this SD button. That's your conversion. You just hit the SD. That converts back and forth between fractions and decimals. All right, so there's our decimal. How would I give this answer? What do I need to do? Round it to where? So what would be my decimals then? 0.806, or you could also just get 805. You can truncate or round up. Either way is fine. So your answer can be 1077.805 or 1077.806. Either one would be accepted. All right, there's our work. And we now have 1 point. Yay! We got a point. We've shown our work, and we found our answer. And we're done with that one. All right, I want you to read AII. See what you need to do for that one. All right, what are we asked to do, guys? So F inverse of 4. Where am I going to look to do that? The table. All right, I have 2 4s. One here, one here. Which one do I want? What is this right here? Is that F inverse or F? So then all of these are F values. So therefore, these ones are the F inverse values. So, which one do I actually want? F inverse of 4 is this. Here's the thing to remember. Let me erase this. So, you have 3 comma 4. That is your, let me actually write this. Your f of x is 3 comma 4. So then, what is f inverse? What's that point as in f inverse? We flip it, right? So in f inverse, that point becomes 4 comma 3. So then f inverse of 4 is equal to 3. We're done. That's it. And guess what? We got a second point. We're good. 2 points. We're done with 2 points. This one didn't really require any work. As long as you had given this, you're good. Please do not just write 3. Write f inverse of 4 equals 3. Write that out. Don't just give the answer. Okay? All right, BI. Find all values of x as, how do they want our values of x? Decimals again. For which g is equal to 3. So how do I do that? G equal to 3, or indicate there's no such values. What is g of x? What do they give us as g of x, guys? X to the third minus 14x minus 27 over, now, g of x equal to 3, does that mean I'm plugging in 3? No, that means this is equal to 3. We are not plugging in 3. Whenever you do this, you have this type of problem, we need to solve for x. Now, would I really want to solve that by hand? Thankfully, what kind of question is this? Calculator allow. So, how do we do this? Well, make this y1, make this y2, graph both, and find the intersection. We have done that before. So, in your graphing calculator, input g as y1, input 3 as y2, graph and find the intersection, yes. X plus 2, isn't it? Thank you. Yeah, you're correct. Whatever g is, that's what we're putting in. All right, so we're inputting it into our calculator like I have right here. So y1, I have g. Thankfully, I have x plus 2 there. y2 is 3. We want to find their intersection. So we graph, and there we are. We have an intersection. However, we need to make sure that's not the only intersection. So what might we want to do with our graph? Zoom out, right? Now, if this was Desmos, remember, Desmos will be allowed. You could just easily zoom out, pinch it out, right? Okay, if you have a touch screen. Here, I have to go zoom and then zoom out, number 3. So I'm going to zoom out. All right. I'm pretty sure that that's going to be the only intersection point. If there's more than one, I need to give both. But I'm only intersecting once. So how do we find that intersection point with our calculators? Where do we go? And not just the arrows, that just traces it. Where do we go? Second trace, I heard somebody say that. Into our calc menu, which one do I want? Number 5, the intersection, right? So it says first curve, second curve is what it's going to ask for. I'm going to move mine over to close by my thing. Please do not just hover it over and say, hey, there's my answer, because that's probably not going to be correct. Say first curve, Second curve, it turned it over to the next one. And then guess. So what is our intersection point? What's our answer for x? 4.875. Again, 3 decimal places. Let's write it as our answer. So that one again, not really any much work, but our answer is going to be x equals 4.875. And we're good. We got our third point. Yay! All right. BII, second part of B. Determine the end behavior of G as x decreases without bound. You express your answer using the mathematical notation of a limit. End behavior, so that's where x goes to negative infinity or positive infinity. Which one do we want? They only want one side. Is it the negative infinity side or the positive infinity side? The left or the right? Which one? I heard some people say it. Lizzie, you said negative. Why? There, right there. X decreases without bounds. X is going to negative infinity. We need to know what those phrases mean. Now, this is the end behavior of G. So, the limit as x goes to negative infinity of G is equal to, well, how can we know that? Didn't we just graph it? Let's look back at our graph. It's right there. What's happening? G is the blue one. What's happening as G goes to the left? Are we going up to positive infinity, down to negative infinity, to a horizontal asymptote? What's happening on my blue graph? Isn't that going up, guys? So, I give my answer here, positive infinity. But, again, you need the notation of limit. We have that. Hey, we have our fourth point. Yay. Let's do part C. CI. Based on the table, which of the following function types best models function f? Linear, quadratic, exponential, or logarithmic? I want you to take your key concepts, open it up to the second page where we had determine an appropriate function types models in the middle of the second page. All right, linear, what does it say for linear? First difference is constant. Quadratic, second difference. Cubic, it's not asking for cubic here. So then on to exponential. What's happening with exponential? Y values are proportional, or in parentheses, multiplicative, meaning we're multiplying by the same thing every time. Logarithmic, what's happening with logarithmic? X values are multiplicative. So let's go to our table. Let's start with those x values. What's happening with our x values here? What's happening every time? We're going up by. So is that multiplicative or additive? So is it logarithmic? Automatically no, because it says logarithmic. X values are proportional, multiplicative. That's not logarithmic. All right, so that means I need to look at my y values. First off, are those multiplicative? Are we multiplying by the same thing? Let's look from 10 to negative 10 to negative 5. What would I multiply to negative 10 to get negative 5? 1/2, right? So negative 10 times 1/2 is negative 5. But is negative 5 times 1/2 4? No. So is this exponential? No, because it's not proportional. So now it's either linear or quadratic. Let's look at the differences. So let's write down our y values here. So that is -10, -5, 4, 17, 34. Let's look at our differences. What is the difference between -10 and -5? Am I going up, going down? What am I doing? Up by how much? So adding 5. -5 to 4. What am I doing? Plus 9. 4 to 17. Plus what? 17 to 34 plus 17. So we've already said it's not linear, it's not exponential. Now, is that first difference constant? Were those the same? No, so it's not linear either. Let's check the second difference. What do we do to get from 5 to 9? Plus 4, 9 to 13, 13 to 17. So there we have it. Our answer is f of x is quadratic. That's our answer. B, or rather CII. Give a reason for your answer in part CI. What was our reason? Why is it quadratic? Second difference is constant. We have a reason. Since the second difference is constant. All right, and we have all 6 points. Your homework. You have 2 practice problems after this. Please note, give your answers in the answer booklet provided on the pages afterwards, these. So this, you're going to give your answers for that FRQ. Put them there. For this one, your second practice, put it there. All right? Have a good day, guys. We'll continue with FRQ 2 tomorrow.